Hi, everyone. So my name is Billy. I'm here to talk to you about reviving the dream of the 90s in WebGL. So before I start, a bit about myself. My connection to the 90s is that I'm a 90s kid. I grew up in the 90s in Vancouver, Canada. Here's me with my family over here, somewhere in British Columbia. And then I studied computer science at university in the US, and now I live in San Francisco, where I've worked as a designer for about 6-7 years. And something that I'm very, very proud of is that some friends and I started this meetup called WFJ about 4 years ago. And it's a monthly creative coding meetup in San Francisco. And we have around 4 speakers every month, 100 attendees every month, and we've been running about for 4 years. And so far, we've raised $40,000 for local nonprofits, which is pretty cool. So back to the 90s. So the 90s were kind of a weird time in pop culture, right? So Destiny's Child had 4 members. Remember that? R.I.P. LaToya Latavia. And Reboot was the first completely computer-animated TV show, and it was made in my hometown of Vancouver, Canada. And Brittany and Justin wore this all-denim outfit, but it's technically from 2001, but I'm going to count it. So what really marks the 90s for me is the exuberance that we had around the technologies that we take for granted today. And here are some examples of what I mean by that. So Nokia, the biggest handset manufacturer of that time, had so many different kinds of hardware designs for each of their phones, right? Like we have the lipstick phone in the bottom right over here that looks like a little lipstick. We have the N-Gage in the bottom left, which is kind of like a proto-mobile gaming device. And then we also had the candy bar that flipped out to be a 2-handed device as well. So a lot of different designs. And nowadays, most phones, more or less, whether you have an iPhone or Android device, they just look the same, big old touchscreen, and that's about it. And even things as pretty mundane as like online movie promotions and how they work, they've gotten pretty standardized as well. So before, you would have these little mini sites for each of the movies that studios would be trying to push. So here's one for You've Got Mail, where they show a bunch of quotes from the movie, and then one for Space Jam. And the Space Jam website is still up, by the way, so you can still see it. And now you more or less get the same kind of promotional materials through YouTube, Instagram, Facebook, Twitter, and whatever. And this tweet reflects the great flattening of expression that I'm getting at, where the natural outcome of technology is that as they mature, they sort of tend to standardize. And speaking from personal experience, most of the marketing web pages that I've designed have been one of these 2 styles as well. So I'm sure a lot of you can empathize as well. So the trade-off has been that we've given up fun and creative expression and personality for utility. So I think the trade-off is kind of worth it. So Nokia phones and 90s websites were usability nightmares, especially if you need accessibility features. But I still want to bring back the 90s spirit of exuberance, where creativity is unbounded by utility and standardization. So to me, when I think of 90s technology, especially software, I think of Windows 95. Where the OS really showed its personality was through its screensavers. Oop. There you go. I know that I've personally spent hours growing up staring at these screensavers. And beyond preventing ghosting on your CRT monitors, they're kind of pointless. But they're also full of personality and fun. So to revive the dream of the 90s, we'll walk through how to recreate these screensavers with modern web technology, such as WebGL. So these recreations will largely depend on A-Frame. And A-Frame is a WebVR framework created by Supermedium. It's built on top of 3.js, a WebGL library, the creator of which is here somewhere. He gave a great talk yesterday. It's easy to set up and has a semantic syntax, so you can declare a box in HTML, like so. And then it'll render a box in your scene. So by the end of this presentation, we'll have recreated these 2 screensavers in our browsers like so. We'll be using technology such as A-Frame, matrix math, and asynchronous functions, and so on to do so. So let's get into it. Let's recreate the pipe screensaver. So here's the original Windows 95 screensaver. So you'll notice that the pipes render in such a way that they avoid colliding with one another. And then they also render one at a time. And then every single time they render, it has a unique palette. And then at the very end, it has this dissolving animation and resets. So at a high level, we'll go through these 4 stages to recreate the screensaver. First, we'll avoid intersections using matrix math. Second, we'll do sequential rendering using asynchronous functions. Third, we'll create a palette on the fly. And then fourth, we'll do a dissolve and reset animation. So let's get into it. Let's go on the first step of avoiding intersections using matrix math. So we'll create two arrays here. One is a matrix to keep track of where you've been so far. So we'll just pick some random point in the matrix to start the pipe. Then we'll consider the adjacent spaces that have not already been visited within the matrix. And then we'll just pick one of them at random. And then we'll repeat this function until we reach some length. We'll just cut off at some length because we don't want the pipe to get too long. And then here, we'll just seed another pipe, go through the same logic, and then choose one and mark it as visited, and keep repeating until you hit the end. So now that we have the data that we want to work with, we'll go on the second step of rendering each pipe sequentially, and within each pipe, rendering each segment sequentially. So a naive implementation of this looks something like this, where you iterate through the array of pipes, and then you call a draw pipe function for each of these pipes. And then within the draw pipe function, we do another for loop to call draw segment for each of the segments within the pipe. What ends up happening is that you end up rendering all the pipes all at once. And you get an effect that's something like this, where all the pipes will sort of pop in. Now, you could use promise chaining using then statements to try to solve this problem. But given that you're going to have dozens of pipes and hundreds of segments within each pipe, it just becomes a bit of a semantic nightmare to handle over time. So what we can do instead is use the await async keywords, which are just syntactic sugar things they can use on top of promises to solve this issue. So when we call draw pipe, we'll use the await keyword to make sure that between each iteration of the for loop, we wait until the function is done. And then within the draw pipe function, we'll use a keyword of async to indicate that it's a asynchronous function. And here's how it works in production. So we'll wait in between each draw pipe function call here. Same thing for the draw segment call here. And then within the draw segment function, we'll add in a bit of a delay to make sure that the segments get drawn sequentially. And here's how it works. So you can see that each pipe gets rendered sequentially, and each segment within each pipe gets rendered sequentially as well. So now that we're rendering each pipe and a segment sequentially, we'll create a unique palette on the fly using HSL. So here's the original again for reference. So you can see here that every single time we render a pipe, we get a unique color palette. And it also has a semi-glossy material on the surface of the pipes. So if you watch the screensaver for hours on hand like I have growing up, you'll notice that sometimes you'll see a little teapot. And it's kind of like a hello world slash in-joke within 3D modeling, where teapots are essentially the hello world of 3D modeling. So what we'll want to do here is first generate a palette on the fly using HSL, and then make it a little shiny using some material attributes. And third, insert in a teapot using external assets. So HSL, what it is just a different way to denote color, similar to RGB or hex. And we can use this to control for colors that are not too light or dark, or not too saturated or unsaturated. So when we generate our new HSL value on the fly here, we'll cap the S, or saturation value, to make sure that's not overly saturated. And then we'll cap the L value to be not too low or not too high, so it's not overly dark or light. Now that we've got our color palette, let's move on to making it slightly less shiny. So the material attribute is pretty simple, and it essentially controls how the surface of the entity looks. And it has a pretty simple syntax here, where you can say material equals some set of parameters. And for example, we'll use metalness, which is how reflective the surface is. And here's just varying degrees of metalness just for demonstration purposes. So by default, it's pretty matte. And 0.3 metalness, that's roughly what we want. And if we crank it up all the way to 1, we can see that it's completely reflective. So lastly, we'll use external assets to render the teapot. So A-Frame can load in external assets to render into the scene. And it could be things like audio files, image files, as well as 3D models. So we'll go to Google Poly, where it's essentially a library of 3D models that you can download and remix yourself. And we'll use this teapot by Google. And then within our scene, we'll declare a assets and declare a asset item, load in the asset using the source attribute, and then give it a unique ID that we'll use to reference it later on. And then in our render teapot function, we'll make sure that we only have one teapot rendered at a time, and then use the ID to refer to the file as we're rendering it. And if we see here in our example, we get a little teapot. And then next, we'll do this little dissolve and reset animation using SVG paths. So here's the original again, where at the very end, it sort of fades out using small black little squares. So to implement this, first we'll create a viewport, and then create a grid out of it. And then randomly mark each segment of the grid with a number. So we render everything marked with 1 first, 2 second, 3 third, and so on. And then we'll render each group as a separate SVG element. Now, a naive implementation of this is that we could render each of the squares as a separate rect SVG element. And what ends up happening is that you get thousands and thousands of SVG elements to kind of handle, and it becomes really slow to render. What we can use instead are path elements. Now, paths can contain some arbitrary shape. And a single path element can render 100 or like 500 squares at a time. So it's pretty useful. So we'll use just a few of these path elements to render the thousands of squares that we need to render. So a path takes in a string as a set of commands, and it can have a bunch of different commands, but here are the 4 that we'll be using. M for move, so move between 2 points without drawing a line. H for horizontal, so go horizontally and draw a line. V for vertical, go up and down. And Z for close, meaning I'm done drawing those shapes, so I just want to close it off and move on to the next thing. So in our code here, first we'll instantiate a string, which will contain all of the commands. And then use M to set the starting point, H to draw a horizontal line, V to go down, H to go left, and then Z to close off the shape, and use a for loop to iterate through all the squares that we want to render within the group. So here's how it works in practice. So you can see here that we're rendering thousands of squares at once with pretty decent performance using just a few path elements. So the 90s is about having fun, right? That's what we set up at the top. So how might we make the demo a bit more fun? So my answer to that is more colors, more interaction, and more memes, I think. So here we can change our palette on the fly. And what we'll do in a few seconds is use the material param to wrap each of the pipes in a different image that we can select on the fly. And like so. So it's like each pipe is covered in a different image. And since it's made using A-frame, you can kind of walk and pan around as the pipes are rendering within the scene, which is pretty cool. So next, we'll render the maze screensaver. So here's the original from Windows 95. So you can see here that we're traversing the maze, and then as soon as you hit a smiley face, you've completed the maze, so it just resets. And then you start to traverse it again. So at a high level, we'll go through these 4 steps. First, we'll generate the maze using depth-first search. Second, we'll solve the maze using depth-first search. Third, we'll dynamically insert in entities throughout the maze. And then fourth, we'll dissolve and reset the maze as soon as you hit the smiley face. So let's go into the first step of actually generating the maze itself. So we'll use we'll generate a maze using a depth-first search algorithm. Here's just a visualization on how that works. And using the data that we get back from the algorithm, we'll generate a maze that looks like this in A-frame. And now to actually solve the maze using depth-first search again. So we'll just pick some point in the maze like so, consider all the adjacent points around it, and then prune the ones that have a wall in between your current position and the adjacent position, and the ones that have already been visited. And just pick one at random. and then follow this logic until you hit a dead end. And then you back out until that condition is no longer true. And then you just keep doing this until you solve the maze. So pretty simple. So here's how that looks in practice. Oops. There we go. So you can see here that we're just solving the maze using depth-first search. So now to fill the maze with other entities that you can look at while you're solving the maze. So the original has a bunch of different kinds of entities that you can encounter, but we'll just implement 3 of these. First is the smiley face thing, where it's essentially the goal that you're heading towards. Second is the rat, which just sort of aimlessly wanders the maze. And then third is the start button, which hovers near where you spawn when you first start the maze. So we want to ensure that the entities don't render on top of each other at the start. So what we'll do is create an array where it enumerates all the positions within the maze. And then we'll shuffle the array to just randomize positions. And then as we're rendering each entity, we'll pop off one of these positions from the array to make sure that they don't render on top of each other. So we don't get the smiley face on top of the rat, on top of the camera, and so on. Now, once we've done this, we'll notice that it doesn't look quite right. Like the smiley face should follow you and look always flat no matter which way you're facing. And in the original here, you can see that the start button looks flat no matter which way you're facing. So to recreate this effect, we'll use a thing called A-frame lookat component. And the syntax for this is pretty simple. We'll set an attribute of look at, and then give it the thing that it should look at, which is a camera for each of these different entities. And now, whichever way you face, the smiley face always looks flat, because it's always sort of turning to face you. And lastly, we'll implement the dissolve and reset effect at the very end. So in the original maze here, you can see that as soon as you hit the smiley face, the maze sort of shrinks down and then builds back up again. So what we'll do here is use the animation attribute that comes out of the box with A-frame. And you can use it to create pretty complex animations like this, which is kind of psychedelic. And the syntax is pretty simple as well, where you can use the animation attribute, give it the property to animate, the value to animate it to, and then the easing that you should use to animate it. And to make our lives easier, we'll structure our DOM like so, where we have a wrapper for the entire maze, and then we have a wrapper for everything that we need to scale up and down at the start and at the very end. And then in our render maze function, which gets called at the start, we'll scale up the entire wrapper along the y-axis like so. And once we hit the smiley face, we'll scale down the wrapper like so. And here's how that looks. OK, so again, the question now is, how might we make the screensaver a bit more fun, capture that 90s spirit? Now before I answer this, I'd like to give a bit of context. So I'll be moving to New York by the end of the month. And as you might know, they have a very big rat problem over there. And there's this really funny article in the New York Times about how the city has struggled with the rat infestation problem basically since the beginning. And there's this quote in there that basically says that one of the city government's agencies spent $1 million on rat birth control, so birth control for rats, in 2013. And they said that it had promising results. But I'm very sad to report that the problem has gotten worse, not better. So 2013 here is near the left of the chart, so it just keeps on climbing up. So New York is sort of entangled with rats forever, basically. So my answer to this question is, more rats. So I just wrote a add rat function that just places a rat randomly somewhere in the maze and makes it go whichever way. So you can see here that as I'm traversing the maze, I can use the buttons at the very bottom to sort of populate the maze more and more and more and more rats, so you get that real authentic New York experience of just rats everywhere. So closing thoughts. So I hope you enjoyed walking through how to recreate these 90s screensavers with me. They really captured that spirit of the 90s where things were just filled with more personality and fun in terms of the technology that we use day to day now. And it's not necessarily a bad thing that we've standardized our technology. There are a bunch of issues around accessibility and usability with such fragmentation in the market. But I want to stress that I like to bring back some of the joy and expressiveness and personality that we used to have with our work. And the thing I want to stress here is that I think we should reject the notion that creativity should be bound to utility. You can use modern web technology to create things that are fun, quirky, and completely useless, but filled with personality. And there's also a bonus screensaver on my site, which I recreated, where I recreated the Matrix digital rain effect. And here's a link with the demo and source if you'd like to look at it. I'll be tweeting out a link to my slides in a little bit. And very special thanks to my friend Visnu Pidiyanavath, who is not here, for helping me a lot with this talk. And that's it. Thank you very much.